Welcome everybody to today's webinar. So what I'm going to do is demonstrate doing text analysis in this low-code, no-code environment. And at the same time, I'm trying to promote this idea that we should be adding text analysis, sentiment analysis in introductory statistics courses. And there's a few reasons why I think we should be doing that. And some of those is because it's easy, right? There's no use of things like p-values and confidence intervals and probability. Those concepts that I think are hard for students in an introductory class to get their head around, right? They're not trivial concepts. Statistical inference isn't simple for those new students. And things like analyzing text data, a lot of it is just counting. You know, you're counting up the use of words and phrases and maybe adding a score or a value or a weight to the use of certain words in an attempt to get a sense of sentiment. So one is, I think it's really easy. So there's no reason why it can't be in an introductory statistics course. And the other reason is how familiar students are with this kind of data. When I was teaching, first teaching at the University of Florida 25 odd years ago, you know, if you ask students, you know, what data are you most familiar with? Well, people would be, what data? You know, they don't look at data. It's not kind of part of their life, but that's very, very different now. I mean, I think the average person knows so much about data. They see it, so they interact with it. You'll even hear words, people drop around the words like algorithm and machine learning, just typical people, because we're used to seeing that, or recommendation engines and all of that. So I think the students are a lot more aware of data, but particularly I think they're very aware of text data. And I think statistical software has made this easy. In, you know, the sort of this no-code, low-code environment, students can kind of interact, point and click, and analyze unstructured text data. And I think because of those three reasons, it's really something that I think we should add to our introductory courses. So I'm going to start off by asking basically this question, and I ask this of students now, which is, you know, what type of data are you most familiar with, or do you see the most? And invariably, the answer I always get back is text data. And I mean, they live in this world, right? Everything from texting and social media posts, or things like restaurant reviews, you know, reviews of products or movies, you know, Instagram, Amazon, Rotten Tomatoes, you know, Netflix. And, you know, people are really familiar. These students, this generation is really familiar with this. This is where they live. And so if that's the case, then really, I think we should add this to our courses. For, you know, if they're familiar with it, I think it's easy to motivate it. And I think they're interested in it. You know, if you say, hey, let's learn some techniques to review all that data when you look at a movie review, and see if we can summarize it and analyze it. And so I think it's easy for students to much more get excited about that than when you say, oh, you know, typical example might be like, oh, we're going to do a t-test on a study done by a psychologist scoring this characteristic and testing a null hypothesis. And that's harder and not as easy for students to get motivated about. But if you say, hey, let's look at reviews of a movie or a product, and we'll see if we can analyze it, I think students like, yeah, let's do that. I'm interested in seeing what happens there. So what I'm going to do here is I'm going to pop over to Joan, and I've got 3 data sets. I should be able to get, let's see, I might be able to get to them all. So I'm going to start off. Now you're going to have to see my eyes go back, and I might shut off my video when you think about that, because I'll be looking at my other screen here. So what I like to do is I often like to start off with a small data set. And the reason why is it's small enough that we can count things and then dig into the actual text data. Right? It's not like we've got tens of thousands of comments or whatever the data is about to review. So this one here is about a product, Bluetooth headsets. And there are 2 products, A and B. There are a total of 97 reviews of the product. Again, small enough that as we analyze this, we can dig into it and count it up. And I think that's a good way to start. Certainly as an assignment or things I'll do next, I'll kind of make the data sets bigger, but I like starting off with something small. So we have two products, A and B, and the reviewers do a few things. One is they give a score, sort of a 1, 2, 3, 4, 5 on what they think of the quality of the product. And if you know how reviews work, there's sort of the summary, right? The headline text that they write, with a little brief little sentence. Like for example, this first person says a very nice headset. This one's like great item, very clear sound. You can kind of see that. And if you look, you'll see some that are negative. Here's one, very poor sound quality. And then they also write something more descriptive. And so this first person, you can see, is going to write a whole paragraph or so that's about the bulk of their review. Now, we're going to do the text analysis on the summary sentence, right? Because really that captured what the review is about. But it may be interesting to dig in. Well, what do they mean by things like this? Especially this person says, great item. Well, what do they mean? And we can go over here and read what exactly they're talking about. So we can certainly do analyses on both of these, but just to keep it simple, I'm going to do analysis just on the summary data. And again, sort of this no-code, low-code environment makes this really easy. And so JMP has a text explorer platform. Literally just put in the variable. And what JMP is going to do, the first thing it does is like, well, let's just count up the use of words and phrases. And so, for example, the word sound is used 25 times. The word good is used 17 times, and so on. Now, something that's nice you can do, and this is sort of illustrating why I like to start off with a small data set, I can click on any of these words and then ask JMP to show me the full sentence, right? So I just clicked on that and said, show me the text. So this first person that has the word sound, this is their summary of their review. Great sound quality, difficult fit for small ears. So there's a kind of a positive and a negative thing in there. Okay sound, very poor sound, decent sound, nice clear sound. Poor. So you can see we've got a mix. So sound is being used both in a negative and positive context. Now JMP will also count up phrases. So I see some phrases over here. Now what I can do is I'm going to bring over, especially because these counts are so small, I'm actually going to bring over all the phrases too. So now in this little graphical display here, this little table, I'm just going to have the counts of words and phrases. Now, for those of you who are familiar with text data, it takes often a lot of curating, dealing with the data, which is illustrating why I like to start off with something small. So, for example, one of the most common used words is the word headset. Well, this is all about headsets, right? So in a way, that's kind of a useless word, right? Of course, you're going to use the word headset. There's nothing helpful in that. And so I can remove that if I want from this analysis. So I'm going to take out the word headset. I don't want that. Maybe even earpiece. Well, actually, before I do that, let me just see what earpiece, how earpiece is used. Is earpiece, yeah, okay. So that's the same kind of thing as Bluetooth. So I can take that out. The other thing you might do is you might combine words and phrases. So, for example, this use of the word clear, this use of the word clear sound quality, just taking a peek at these. So I may decide, you know what, let me combine those and just count those as one thing. And so I can just right click on that. And I'm going to say recode, and then I just got to give it a name. I'll just say clear sound. Recode, and so it's brought those together. So this often takes a lot of that work, right? Bringing things together. Oh, here's another one here. Good sound quality, that maybe I wanted to add that to clear sound. nice clear sound, same thing. So I'm not going to do all of that, but that's pretty common with what you have to do is you have to sort of take out words, combine words and phrases, recode things. And with a small data set like this, it's easy, right? It's easy to click on one of these things. And if you're just seeing 3, 4, 5 reviews, right, you can kind of quickly see if those words or phrases are used in the same context and justify combining them. Okay, now something else I like to do is, well, we have 2 products here, product A and B, and then we also have these ratings. And so something that's really easy to do in JMP is I can bring up this thing called the data filter, and I'm going to do products and their score. Okay, so over here on the left, I have this thing called the data filter, which allows me to subset the data, and then those tables and little displays on the right are only going to be based upon how I've subsetted the data. So for example, I could say, well, let me look at product A. And so now JMP just recounted these words and phrases, and I can bring some over if I wanted to. And I can say, okay, for product A, what are these frequent words and phrases? And I can look at some of them. So I'm just going to click on the word sound and see how product A's, when somebody uses the word sound, clear sound quality, nice clear sound, good sound, great sound, sound is clear, clear sound. Okay, so that's tends to, that's all positive for product A. If I go to product B, okay, I can also look at, let's see, don't have the word sound. I'm going to look at, oh, well, here's poor sound quality. I can click on this. And so now in product B, I'm saying, maybe there's a little bit more negative comments. Sound, oh, here's an example. The word good is used negatively, sound not good. So because this is small, the same thing, I can click back and forth and then try to get a sense of how product A and B are. Now I'm going to do this a little more formally because I'm going to score those words, but just showing you there's a lot of stuff I can just do right here. I can also see if I want, what are the words used for, say, people that give it a score of a 5, or any of these products a score of a 5, or I could pick a product, and I can see what are the attributes that might be the reason why they're giving a high score. I could also click on the lowest scores. I'll do 1 and 2, and I can see what words that are being used there. So real simple, right? Students can understand this. They're just digging into these words and just trying to summarize them, counting them up. But they're certainly getting a sense of how people feel about these 2 headsets. Now the next thing I'm going to do is, I'll show this first. I mean, people like that word cloud, so I can choose to display the word cloud. Because people like centering, so I'm just going to see. This is just another visualization of this table up here, but it's so common that people like to see that. So you might as well do that. I can even if I want. This is actually, I'll go back to the filtering, right? So I can filter by the product or the overall rating. I want to see that word cloud change. But what I'm going to do is this next thing I'm going to do is, hold on one moment. I'm going to just do, well, maybe I'll save this. Yeah, I'll save sentiment analysis for the next day. I just want to start with this simple one. So where, again, we're just counting up words and phrases. Pretty straightforward. Before I move on to sentiment analysis, where we're going to take text data and try to give it scores, any questions? You want to type in the Q&A before I move forward? All right, I will move forward. So I'm going to open up a data set. This will be a bigger data set. For sentiment analysis, I want to have a lot more data to do that. So this data set is about reviewing coffee pots, right? So those little 1-cup coffee machines that you see a lot there. You put the little pot in, And so this one is a much bigger data set. We have over 18,000 reviews. And now this is all the same product, so we don't have like that product A and B like we did the headset, but I have the scores, 1, 2, 3, 4, and 5, and you can see most of them score higher. I'll just show that larger so you can see. All right, so you can see most of the scores are larger, is the average. Just kind of getting a sense of that. So let's do the text. And now I'm going to do it on this summary sentence, same thing, but I've got this bigger detailed sentence if I wanted to do it for that. And so this is going to take just a little bit to run here. Give it a second. So 18,000 documents, a little bit longer. All right. Let me close a bunch of this stuff up here. Okay. All right. So we've got those words and phrases, counting them up. Now, the same kind of thing, and I'm not going to do this, but you would go in and do that combining of words, taking some words out. So, for example, the most frequently used word is the word coffee. Well, that's kind of a, sort of not an informative word. Of course, we're talking about coffee pot, so people are going to see the word coffee. So if you go through here, maybe we would take out cup or cups, and then we would maybe go in here and start combining things. So we might take, delicious, and we may combine that with tasty, right? So you can sort of see that. So there's always a part of analyzing text data where you got to do a little work to reduce it down to data that's the most meaningful. And so we might do that. Same thing with phrases. We might be going with phrases or take phrases out. So for example, K-cup, K-cups, well, that's what the product is. So same kind of thing, we might take that out. Now there's a lot more here. So if I clicked on something like flavor and say show text, well, now I have 750 of these to look through. But you can certainly, what I like to do is, I guess I could say like I'm randomly sampling, right? I will sometimes scan through and just to get a sense. But we're going to do something a little bit better to count these up and score them. Okay, so what I can do is I can ask JMP to do a sentiment analysis. And let me close all these up. So I already did the analysis. That's why it's sitting right there. But I basically just went in and basically just asked JMP to do that for me. Okay, so a couple of things to show you what JMP is doing. Okay, so built into JMP is a dictionary. And so here's a dictionary over on the left. And so I'm just going to sort of scroll through. And so there's a list of words that JMP has built into this dictionary. And then it's giving a score for the use of that word. Now let me see if I have words that I might want to grab. Let's see, if somebody says the word fabulous, it's going to give it 90 points. Now you can change that by just typing in a different number, right? So I'm seeing words that are used and scores. And over here is a table of words that JMP is seeing in this data set and suggesting, hey, these might be words you want to add. So for example, the use of the word strong. Now, strong is going to have one context for coffee. It's going to have another context for something else. And so over on the right, I can see how strong is being used. And people might be using it negatively, like too strong. Someone might say nice and strong, right? So there's a little bit decision of like, how do we want to score that word strong? If we want weak, I think we would all agree that that's negative. So we can decide, hey, let's add weak to our dictionary and give it, I don't know, minus 60 points or whatever we want. The other thing you can do is you can load up a dictionary. So you might say, look, I'm going to really reduce this down to a set of 50 words or something like that. You can just have a little text file of those words and bring them up. Because again, the product, or whatever you're doing, words are going to have different context, right? If it was a movie review, the use of words there are going to be unique to movies. People would talk about movies, and that's going to be different than if you're talking about coffee pods or Bluetooth headsets, or you're looking at social media posts, for example, or maybe looking at posting about how people feel about a political issue or something. So you can create your own dictionaries if you want. So things like, like tasty, right? That's certainly something I want to add. I won't do this, but I can go ahead and start adding these if I want. Now, the other thing that JMP is doing is it's adding sort of this intensifier to it. So if somebody said good, let's see what good is here. Get the score for good. So good is, where's good? So right now, good is 60 points. But if someone says good and another person says very good, I might want to treat those differently. And so there's a whole set of words that are describing an extra sort of attribute about each of those words, and it adds that as a multiplier. So if somebody says very good, I'm going to take the score of 60 points and multiply it by 1.6 and give that a score. And I can change those if I want, so just kind of go in there. And the same thing, I can add unique intensifier words if I want, but JMP has a built-in set right here. And then the other thing JMP has built in is negation terms. So for example, if somebody says good, and that's 60 points, if they say not good, I'm going to give it minus 60 points, right? So there's this negation term, which basically just switches the sign from positive to negative or negative to positive, whatever is the use there. And you can build this in yourself. Now, with just that, now I skipped to this data set because I wanted to do something a little bit bigger, but we could have done it with the Bluetooth headset, and you can see that was small enough that really people can kind of almost go through every review and really sort of decide on the appropriate scoring for everything. This one, 18,000 is a little bit too big to do that too. So JMP basically just goes through and comes back and says, well, I'm just going to go through all of these reviews and score them up. And so this little table right here is going through all the documents and that I can put a score on, and I can click on them and see here, right here is that summary review, right in that little gray box there. So I could click on these to see these scores, and JMP is doing two things. It's scoring positive and negative. So let me see if I can find one that's doing that. Here's one here. Disappointing presentation, fantastic assortment. That might be one where I'll dig into the longer text to see what that person means there. Let's see if I can find another. Here's one here. Oh, yeah. Now I know what happened with this data set. This often happens when you grab it. There's a mix of some other products in here. So I'm going to assume the dog isn't drinking coffee. So there might be something mixed in here. So there's a kind of a combination. Somebody's using the word great, but they're giving a negative review of the price of it, which brings up another element here is, but before I do, I'm getting a summary of all those scores, right? And students can get this. You just do a little chart of the data, a little histogram of the data. It doesn't take much to see that most of these reviews are positive and there's some negative. And again, you can go in there. Now I just filtered by them. So I can see how I can grab all of them. So I just grabbed all the negative ones, and now I can scroll through and see all the reviews that are negative. Something else JMP will do is it will scan through the text data and hit search, and you'll see, and it will find words and say, well, these are features people are talking about. So for example, there's people who are using the word taste, flavor, that I'd probably group those together. Taste and flavor are probably the same, maybe tasting, taste. You can see all these words here that refer to the taste. So Jump is saying you can grab one of these. Now I will grab price. And so these are all the people, there's 269 of them that are talking about the word price. And you can see things like great price, awesome price, good price. But there's also some people that say not so great price. So I can do that and then say rerun the sentiment analysis, but subset it on the data where people are talking about price. And so I can hit score and it's going to rerun this. Open this back up. And then this is the sentiment analysis, right? Scoring these reviews, but now these are only ones that are talking about, they have to talk about price inside of their review. So it's much fewer, but you see that they use the word price. And so this allows you, this concept of features is you can say, well, let me talk about, or look at the reviews when people are talking about price. Let me look at the reviews where, say, people are talking about flavor or whatever this happens to be about, right? So if it was about a movie or a book or a song, right, the descriptions would be using different words. And so I can go in there and subset the data according to that. Now, again, nothing sophisticated. This, we didn't, in the in the headset data, we just looked at the words and phrases. Here in this coffee data set, now we're adding values, adding some numbers. This isn't hard for students to get. We're just counting things and saying, hey, if this word is used, give it 20 points. If this word is used, give it minus 30 points or whatever it is. Very, very simple. We can summarize the data with histograms and means. Very, very easy to do. Okay, I'm going to close this example up and open up a third data set. Where I'm going to kind of expand a little bit beyond counting up words and phrases and scoring them, but I'm going to bring in some other variables. But before I do, let me just check the Q&A or chat. I see nothing there, but I'll give a second to see if somebody has a question. I will be closing up this. Here we go. There's a question about the weighting. I don't know the how those dictionaries were created, but I'm going to guess to your point is it's not just some arbitrary thing. It's probably based upon sort of standards of natural language processing and all of that. But I don't know much more than that. But you can bring in other languages, right? So that's nice. Or as I said, you can create your own dictionaries to really reduce this down and target to something. All right, so I'm going to close this up and I'm going to bring up a third example. Now, what this example is about is in Toronto, they're considering opening up a casino, and so they send out this survey to folks that live in the area, asking them a whole series of questions. And what I'm going to focus on is basically this question right here, this first question, which is how in favor or not in favor are you of Toronto putting a casino downtown? And then, giving that score, right, strongly in favor all the way to strongly opposed, and then give a list of reasons. So for this data set, I've got their answer. And I could also turn that into a number, and you'll see I'm going to use that number later. I did that. And there's 3 reasons. So I have this in 3 columns: reason 1, reason 2, reason 3. But what I just did is I just combined it into this final column here. So this is just where I'm taking their 3 reasons, bringing all the data together. Okay, so let me actually see how people feel here. Just a little graph here. Okay, so you see most people are strongly opposed. At 60, almost 66% are strongly opposed. And then if I added somewhat opposed in there, that totals about 71%. So quite a bit more people are opposed to this that are in favor of this, but let's go in and see if we can learn the reasons. And Let's run the text analysis. Yes, the question about combining words and deleting words, you might have missed that. I did that in the first example. Yes, when you look at these words, and you'll see when this count comes up here, there's almost 13,000, so just give it a second. I can go in there and group things together that make sense. I can take words out, and maybe I'll just show you one or two examples when this comes up. This is finding we're rating, but I remember when I was in graduate school or early on, and some of you, you know, if you're about my age in your 50s, you probably remember this, where you would, at night, you would submit your code, like maybe it was SAS code or something, and you would submit something at night, and when you came in back to school in the morning, you'd see if it rained or if there was an issue. So this isn't waiting too long, but back in the day, we still wait a lot longer. Okay. So here I've got, you know, the words and phrases, counting them up. And you know, this was an analysis I had already run, so I cleaned it up. Let me just see. I'm going to just do it one more time. Just do it with a smaller set. Let's see if this goes a little quicker. Okay. So I already had taken out some words, but I just ran it again so you can see. So for example, here's a case where the second most frequently used word is city. The fourth most frequently used word is used Toronto. Third is casinos. Fifth is casinos. I'd probably take all those out because, well, they're talking about a casino in Toronto. So these aren't that interesting. They're not that informative. So I can just grab those if I wanted to and just manually take them out. And the other thing is I can combine words, and let me see if I have something here. Let's see, I might take, now I asked JMP to sort of stem the words a little bit. So anything with like an ing, I can combine that, but I might go through here and decide. I was hoping, oh, maybe over here, this would be perfect to combine, like gambling addiction, gambling addictions, problem gambling is, I would probably take those. And I'm going to sort of bring those into one word. Same thing over here. I might add addictions and kind of bring that in. So okay, let me just count that as one thing. Okay, but let me get. So you do that, but it will take a while to do. So right here, I have my counts and words and phrases, and I have it filtered by all these other variables. Like, for example, I can look at different ages. So I've got the survey responder told us their age. I can also, if they gave us their gender, I can do that. So I've got female, male, and prefer not to disclose. And so I can filter by that if I want, filter by both age and gender. And then I also have, so this was the data filter I set up, and I also have postal code. And so that probably affects what people say. So there's probably people in communities that are right near where the casino is going to be, and they're the ones that are going to deal with any of the issues that come up, like traffic or whatever happens. And so I can filter this if I want by different zip codes. So just to make something up, let's say this little group here, these are all the ones that are the closest to the casino. Now I can see what words those people are using, and then I can pick the ones that are, say, furthest from the casino and see what words those are. Okay. Now, what I can do from here is I can say, okay, John, do this thing called a document term matrix. Now, I already did it. Let me show you. I'm going to scroll over. So I asked JMP to take the words that he used most frequently. You can see like revenue, gambling, addiction, jobs, crime, tourism. And then it's just giving a binary score of a 0 or a 1 if that person used that word. So think about, oh, I got all that text data. Now I'm turning it into numeric data. So I got this unstructured text data. I'm going to turn it into numeric data by counting. I could also not just make it binary. I could count the frequency of using a word if I wanted to. So how often they said it. But binary is probably sufficient. So now I've turned text data into some numeric data, but nothing too sophisticated here for an intro class, right? So now I can make all sorts of little charts if I want. So here's a little mosaic plot where I can plot the use of the word, each of these words. And so I'm clicking through, and basically you got 0, 1. Blue is 0, 1 is red. And so I'm seeing the proportion of times people are using those words and by each age category. Or maybe I want to break it down by gender. And so now I can go through a series of these graphs to see if there are differences between those different types of people, their gender by age, or maybe I could do postal code if I want. There's just a massive number of postal codes, so I didn't. And then I can just see if there are differences. So again, pretty simple if you're talking about histograms and bar charts and those kinds of things in an intro class. This isn't hard for people to click through and ask them to like find some features, point out 3 to 5 interesting features you found in the data. And I think any student could kind of click through here and they could probably find the ones that are the biggest difference and comment on it. Now, if you were doing something more formal, so let's say you were teaching chi-square analysis, contingency tables, well, I can do that. So basically, I've got the same graph over here, a little mosaic plot, but what I'm adding to it is down the bottom is I can add a contingency table and a chi-square analysis. So if you were at that point where you were teaching inference in class, you'd say, hey, now that we've turned all this text data into this numeric data, let's actually run some formal analyses and see if we can find, right? You can see there the p-values right there. So as I click through, you're going to see the ones that are significant, from the ones that are not significant. If we're, in this case, we're comparing gender, female to male in the use of these words. And if you had a student go through this, whether they were doing the formal inference or just graphing, I often said I'll ask students as part of the assignment, just point out, 5 to 10 features you see in the data that are interesting that we've learned from this. And I think intro students would have no problem. And the other thing which I think is fun is if you want students to do it as like a project, is to say you go out and get some data. That becomes a little more interesting to them because then they can focus on something they're interested in, right? So if they're interested in movies, they can grab movie reviews, or they can grab social media reviews if they're interested in that, or if they're interested in politics, they can look at commentary about a political issue. And so this, I think, is much easier because how else are students going to get data, right? You can't go out there and have them do a study or a research study or run experiments. Right? That's not always easy to do if it's engineering or something, right? But stuff like this, we can say, hey, go to some websites, download some of this data, throw it into JMP and start analyzing it and see if you can, learn something from it. And whether you just summarize the counts and frequency of words, whether you add sentiment analysis to it to score the words, or you go all the way up to the point we did in this last example, which is to now take that text data, turn it into numeric values, and then start doing analyses by bringing in other variables. And you can even go further with this. I mean, now that I have this binary value, if I can do logistic regression, if I had that kind of other variables to work with, or ANOVA, whatever would make sense once I turn it into data. So you can kind of take this far if you want, but really what I wanted to focus on is how easy it is to do, and especially in this no-code, low-code environment, and that familiarity students are going to have with this data, the interest I think they're going to have, that I think this is really something that I think we should all consider adding to our introductory statistics courses. Okay, so I think that takes us to quarter of, and let's see if there are any more questions.
Yeah, so that's the presentation. I know you answered the last one about the combining words, or you were talking about that. Were you able to look at the other two? The first one is jump typo agnostic in word counts and sentiment scoring.
Oh, well, if it's a simple typo, so let's say somebody said the word, well, you know, it would have to take it out of the root word. If the root word is spelled wrong, that's probably not going to combine those. But you can do that manually, right? So that's kind of the point of, and that's the thing about unstructured text data. Like you got to do a lot of like looking in and digging in, because you're probably going to see that, oh, people are spelling the words. Can I combine them? But if you created a dictionary, you could possibly do that. Now, I don't know if some of that's built in. I'm gonna think no. But if you yourself created a dictionary and said, okay, these are the 4 types of spellings that people are using, let me count those up and treat those the same or score them the same with sentiment.
All right. Jamin Kim has a question regarding intensifier terms. I'm wondering how the weighting for each negation word phrase is created. Is it based on linguistics theory?
Yeah, I'm going to do something here, and let me see. I'm going to go to help. Oops. I'm just going to go in here and I'm going to see if there's, I'm just in the help menu here, and oh, and this text analysis platform can do a lot of things like clusterings. You can get in there and do semantic analysis and trying to group, documents together. I'm just trying to see if it gives any. Sometimes you'll see in here, it will reference the statistical details. If you click through here and read, you might find something, but I don't know. Yeah, I'm just clicking through the use of, but again, we're data science statistical software company, so whatever was created, I'm going to trust that the R&D and product development team, right, they're doing something that's sort of consistent in what the literature and the research suggests that is being done here. But I don't know, but I can't imagine it being not sort of satisfying those kinds of approaches that are expected in this kind of technique.
All right, so we answered that. And then you answered the last one, which was, is there any way to combine words or delete unwanted words automatically, not manually? I don't know if you want to go over that again.
That is, you have to do it manually, but if you built your dictionary a certain way, you can decide, right, which words you want to use, and then like really reduce the dictionary and say, I'm just going to use this really small set. And then hence it's only going to base it on that dictionary. Oh, Muafa, hi, how are you doing? Yes, I will reach out to you. It's funny, I had a note to do that back in early 2020, but something happened and that stopped everything. But yeah, I remember BJ was telling me that you had went on to Menlo College. I'll reach out to you. Would love to connect.
And that's it for our questions that we have here in the queue. Unless there's anything else you want to put up, emails or anything. Obviously, all of this has been recorded, and we will be posting this for those on here who want to review, or others who signed up today but weren't able to join us for one reason or another. Kevin, any last words or anything else that you want to share before we sign off for the day?
No, I think that's it. Thanks everybody for attending. Appreciate it. And oh, you know what I'll do? Let me type in I'm going to put my email in the chat. If you want me to show you other things about JMP, do a little presentation, customize it to specific things you want to see or your colleagues want to see. I often do guest lectures, which goes over well with faculty because I've been a statistician for quite a while. That I'll do guest lectures where I'll share with students and what I've learned over the years, best practices, things I wish I knew when I was their age that took me a long time to learn, or I walk through like a project I've worked on to show them, hey, these things you learn in class, this is how they get used in industry. Here's a real project I've worked on. So don't hesitate to reach out. We'd be happy to do a presentation or answer specific questions or show you very specific platforms in JMP. So just feel free to email me.
And I'll put a plug in for the Informs annual meeting. Kevin, are you going to be there?
No, one of my colleagues is going to be going instead.
Wonderful. Well, hopefully we'll see other ones there. I know Kurt will be there. Is that right? Yep. So Kurt Heinrichs will be there from JMP and manning the booth, and I'm sure seeing everyone around. So obviously, if you're coming, take a look and stop by. But hopefully you'll see we'll see some of you there, or hopefully many of you there in Indianapolis for our annual meeting coming up in just a couple of weeks. That's all for today. I really appreciate everyone joining. Kevin, really appreciate you sharing all the insight into the software. Obviously pretty cool stuff, and appreciate your time and appreciate everyone else's time for joining us today. This meeting will be posted, or this webinar will be posted shortly. Again, for those who want to review it, or for those who couldn't join today, on behalf of JMP and Kevin and his boss Kurt and all our friends here in Informs, I want to thank everyone again and have a wonderful day.
All right, take care, everyone.